6 gets to the meat of algebra, the quadratic function. The function negative 16k squared plus 33t plus 3 is a quadratic function. A quadratic function is an equation in two variables that can be written in the form ax squared plus bx plus c equals 0. So let's identify each one of these. We have an a term, and our a term is the term that is the coefficient to our squared term, the x squared term. Okay, we also have a b term, and the b term is the coefficient to the x term. Whoops, the x term. And we also have a c term, and our c term is the constant term. Okay, now notice when I identified those in the different colors that I kept with them the integer sign, not operational sign, but the integer sign. So when we're writing this, our a is equal to a negative 16. Our b is equal to 33, that's a positive, and our c is equal to 3. That was also a positive. But make sure you keep those integer signs with the term. All right, so how do we evaluate a quadratic function? So we have another quadratic equation here. We have 2x squared plus 3x. Let's go ahead and circle them. That'll be easier for you to see them then. Plus 3x. And then we have, whoops, that was in red, I think, plus 1. So there are our terms, our a, b, and c terms again. Now, the first thing we're going to do is we're just going to evaluate this. And by doing that, we're going to simply substitute some values of x into the equation. So if I substitute a negative 2 first, it would be 2 times negative 2 squared plus 3 times negative 2 plus 1. I've substituted in my x. Okay, negative 2 squared is going to be 4. Negative 2 times negative 2 is 4. So I get a positive 4, and then I need to multiply that by 2. So I'm at 8. Plus 3 times negative 2 is negative 6. Let's go ahead, and this is going to get kind of close here, but I'm going to write this in here. Plus 3 times negative 2 is a negative 6 plus 1. So 8 minus 6 plus 1 is going to give me 3. All right. Let's see how I can. I'll make this one a different color and try to write a little bit smaller with this one. So this time I have 2 times a negative 1 squared plus 3 times negative 1 plus 1. Okay, if I multiply that one out, I'm going to multiply this one out over here to the side just so that we have enough room. So 2 times negative 1 is negative 2. Oh, sorry, mistake, I forgot I was squaring it there in my tininess. Sorry, I need to do negative 1 squared first. Negative 1 times negative 1 is positive 1 times 2 gives me my 2. Plus 3 times negative 1 will give me a negative 1 plus 1. So I have 2 minus 3, which would give me negative 1, plus 1, which will give me 0. All right, substituting the next one in. 2 times 0 squared plus 3 times 0 plus 1. This is nice. We won't have to do too much figuring. Anything times 0 is going to cancel out. So this answer would just be 1. Okay, and we will continue. I'll switch colors again here. 2 times 1 squared plus 3 times 1 plus 1. We'll figure it over here to the side again. 1 squared is 1. 2 times 1 is 2. 3 times 1 is a positive 3 and a positive 1. So we get 6 for that answer. And our last one, 2 times 2 squared plus 3 times 2 plus 1. Let's figure it out over here again. And we're going to have 2 squared is 4 times 2 is 8. 3 times 2 is 6, plus 1, and so that's a large one. We end up getting 15. Okay, because that got kind of messy, I'm going to, I guess we're going to do a second one anyway, so I was going to put that one on the graph. So the next example, example 2, we're going to do the same thing, but we're going to see how they look when we graph them. I got a little ahead of myself. The graph of a quadratic function is a terrible spelling here, U-shaped curve called a parabola. I'm going to give you a warning. I was saying hyperbola for some reason in the other classes. To make sure I'm always saying parabola. You can catch me on that. A quadratic function is an example of a non-linear. Linear means this would be a line. Wow, just tons of typing mistakes in this one. A non-linear function is any function whose graph is not a line. Linear means line. All right, so this time here is our equation. You're going to notice in this equation that we have an A term, but then we don't have a B term. We only have a C term. That will come up later, but I wanted to identify those terms for you. Okay, so we're going to go ahead and I'm going to do the substitutions over here. I left myself some room, and then we'll put our answers over in the chart so that it's easier for us to see that for when we go to graph it. So we're going to start out, and I'm going to start out with even numbers. And the reason I'm going to do that is because of that half in there. That multiplying by a half, that will just make things a little bit easier for us. So I'm going to do 4, 2, 0, negative 2, negative 4. Okay, we always have 5 points when we're doing a parabola, and you will see it in a minute when we graph it why that's important. So let's go ahead and we're going to do 1/2 4 squared plus 1. So 4 squared is 16, and a half of that is 8. So 8 plus 1 is 9. Okay, so our first coordinate point would be 4, 9. All right, let's do the next one. 1/2, and this time we're going to square 2. It's going to be what we're inputting for our x. 2 squared is 4. A half of 4 is 2. 2 plus 1 is 3. So our next point is 2, 3. 0, we like zeros because that just cancels them right out there. So doesn't matter on this term here. That's going to cancel out, so this answer would be 1. 0, 1. And then we have negative 2. Now, negative 2, when we square it, negative 2 times negative 2 will give us 4. So that's the same as our positive 2 in this one. So that answer is going to be 3. And the same is true for our negative 4 when we square it. So that answer there is going to be 9. Negative 4 times negative 4 is going to be positive 16. Half of 16 is 8, plus 1 is 9. So our last two coordinate points are going to be those two. Now, just looking at the points before I even graph, you should notice something. You should notice that we have some mirroring points. And that's going to make a little bit more sense in just a minute when we go to graph this, and you will see what a parabola is. So let me see if I can get my, didn't get the whole thing there. If I can copy, I don't think I'm getting my negatives in there, but I can put those in there. I'm going to copy that and paste it on the next page. And let me write those negatives back in there again. This was when we substitute negative 2 and when we substituted negative 4. Okay, so there is our input-output chart. I might keep that over just a little bit more. Doing it with the stylus, so it's being a little bit touchy. Okay, there are the points that we ended up with when we were substituting into the input-output chart on the screen before this. So let's go ahead and let's chart these now. So we have 4, 1, 2, 3, 4, and then up 9. So 4, 9. We have 2 over 2 up 3. Same routine you did before when you were doing linear equations. Negative 2, I go to the left, and I go up 3. And negative 4, I go to the left, and then up to positive 9. And you will see what a parabola is. Hard to trace it. And that is a parabola. We're going to have a special point here. This one's called the vertex. And we're going to have these mirroring points that will give us a parabola. A parabola also has a line of symmetry, and you remember that from the past? If I can get that up to show a little bit better. That means if I put a mirror up there, I would see a mirror image in there of the same points on the other side. We can identify the vertex by the one point that is in between those mirroring points that I identified before, the 3 and the 9. All right, moving on then. We have that U-shaped curve again, and same terrible spelling because I went ahead and just copied and pasted that. So let's not make it a punctuation, and let's make this a U-shape. And we'll go ahead and do the same routine we did before. So I picked some points there for your input-output, and we're going to put in negative 2, negative 1, 0, 1, 2, and 3. Right? When I put in my negative 2, we're going to put in, now notice this is a negative x. So I want to put in a negative, and the negative 2 only replaces the x term. Plus 2 times negative 2 minus 1. Okay? When we work that one out, let me get rid of my little vertex box here. I think it is locked on there, so it'll take me just a minute. I'm going to get rid of that for right now and lock those back up just so I don't mess them up when I'm writing on there. Okay, and I'm going to go ahead and I'm going to work it out and then write my y down. So let's work this out. Negative 2 squared is going to be 4, but then I have the negative outside of that term. So positive 2 times the negative 4 is going to be another negative 4 minus 1. So if I total those up, I have negative 4, negative 4, negative 1. That's going to result in a negative 9. So when I have negative 2, when I substitute negative 2, the result was a negative 9. Okay, let's do this one. Negative 1 squared, again this is my x term, plus 2 times negative 1 minus 1. Negative 1 squared is 1, however there is a negative outside of there again, so negative 1. 2 times negative 1 is going to give me a negative 2, and then that's minus 1. So negative 1, negative 2, and negative 1 is going to give me a negative 4. So when I substitute a negative 1, the result was a negative 4. 0, we like that one again because that doesn't matter for squaring it, and it doesn't matter for integer signs. So this is going to cross out, this is going to cross out, and our answer is going to be negative 1. So 0, negative 1. All right, let's put 1 in there. We have a negative 1 squared plus 2 times 1 minus 1. 1 squared is 1. That should be a negative 1. 2 times 1 this time is going to be a positive 2 minus 1. So we have negative 1 and another negative 1 is negative 2 and a positive 2. That's going to be 0. So 1 results in 0. Getting kind of tight and sloppy over there. I'm going to go ahead and negative. Our x is 2 squared plus 2 times our x, which is 2 again, minus 1. 2 squared is 4. It's going to be a negative 4. But now 2 times 2 is a positive 4 minus 1. Those two cancel each other out. So we were substituting in 2 for our x, And the result was it equaled negative, oh, that's too sloppy there, negative 1. Negative 4 plus 4 is 0, minus 1 is negative 1. And our last one, our negative, our x is 3, 3 squared, plus 2 times 3 minus 1. So 3 squared is 9, we have a negative 9. 2 times 3 is 6, positive 6, minus 1. Let's combine our negative terms. Negative 9 and negative 1 is negative 10, plus 6, we're going to end up with a negative 4. And that was when we substituted our 3 in for our x. All right, let's go ahead and copy those points again, and then we'll identify some of those when we go to graph it. Move this up if it'll let me. Oh, it's nice cooperating there. All right, so one of the things we talked about on the last one was we're going to look for that mirrored image. So I have a negative 4 here, and I have a negative 4 here. I have a negative 1 here, and I have a negative 1 here. That makes this one here my vertex. That means it's going to be the point that my parabola starts at. So I'm going to go to that point first. I'm going to go over 1 and then up 0. That's going to be my vertex. All right, let's plot our other points. Let's do our 0, negative 1. Don't move up or down, or don't move to the side, and I move down to negative 1. Negative 1, 4. Go over to the left, go down to negative 4. And negative 2, go to the left 2, and down to negative 9. My, those are blurry on my screen there. All right, and now let's go to the ones below here. We have 2, go over 2, and I'm going to go down to that negative 1. There's that mirrored point, and over 3, and down to negative 4. And there's the other mirrored point. When I draw my parabola, we're going to see, and if we would have went to another point, we would have seen that mirrored image. Now, a couple things to point out from, we were just substituting in some random points, some easy points like we did with input-output charts, but there's a couple things I want to point out. There's a maximum and minimum value in a quadratic function. The value of A, sorry, this should be your A term, which I believe we were marking in red, so I'll go like this. The value of A indicates whether it's going to open upward or downwards. Okay, so let's go back to our graph. Oops, one more. All right, and I don't have my equation written here, so let me write my equation. My equation was y equals 1/2 x squared plus 1. So let's write that down here. Y equals 1/2 x squared plus 1. That's a really ugly 1/2. Makes it a little bit better, I guess. No, looks like a cube. All right, so if I look at each one of my terms again, I believe I did my A term is going to be in green. I didn't have a B term because I don't have an X, and my C term is my constant. So if I look at just my A term here, my A term is positive. That's my A term. My A term is positive, so my parabola is going upwards. It's opening upwards. Okay, if I go to my next graph, and let's write down that equation. My next graph was, I was using the equation negative x squared plus 2x minus 1. That was our equation we were using here. Let's identify each one of our terms. This is my A term, which my A is a negative 1. That's the coefficient to my x squared. My B term is going to be, whoopsie, do that over. Got to get that operational symbol in there. A positive 2. And my C term is a negative 1. Now what we have just learned is that if we look at our A term is negative. I'm not writing very good over here. And negative means that my parabola is going to open downwards. Now, in one that is downwards, this is going to be my maximum amount. And in a parabola that is opening upwards, this here will be, the vertex here, will be my minimum amount. These don't want to work today. So that concludes quadratic formula, which will be the meat of moving on to anything in algebra.